All right, welcome, ladies and gentlemen, to another live stream. Actually, I want to do something a little bit different. So every Sunday night at 9 p.m., I go live and I answer questions that you guys go ahead and submit. Well, last night I went live and I was answering questions in the chat, and it became a little bit more than I could handle. So rather than staying up till midnight and trying to answer all your questions, I decided that I'm going to try to go live, or actually, I'm not decided. I am going to go live each and every day this week, and I'm going to try to stick to this time at 4:30 Eastern time PM, and just to go ahead and try to get through some of the backlog. And then also, I know that some of you might be finding this live stream for the first time, and if you want to go ahead and submit a question to me, then you guys can go ahead and do that. So even if you can't make the live stream, don't worry. I'm not going to take these live streams down, but you can go ahead and submit your question at brianmclogan.com/Q&A. And therefore, I will try to do my best to answer your questions, basically answering everything from like algebra 1 to pre-calculus, mostly, sometimes a little bit of calculus, but I'm trying to avoid, word problems or like problems that are going to take a really, really long time because yeah, it does take a long time. And I know that some of you are still in school or you're in sports or activity, like it's not a good time for you. So again, feel free just to submit your question and I will try to get to it. Just to kind of give you a heads up, I'm going through, probably try to keep this like, I don't know, roughly around 30 to 40 minute kind of stream. And then also, just to let you know, this is a completely free stream. To submit your question is absolutely free. However, if you are taking pre-calculus and you are like, I really need a lot of help, then I do have to do a little plug for my pre-calculus course because it is a lot. It is a lot that brings in a lot of benefit. So what I'm doing right now is also something I'm going to do for anybody that purchases the pre-calculus exam course. I'm going to add in some extra live tutoring sessions that are going to be private, unlisted. Therefore, you can kind of ask your question in real time. And those will be recorded. Again, same thing. If you can't make the time, you can always go back and see the recording. You submit your questions, but it is only going to be for pre-calculus. I just don't have enough in order or time allowed for all the other courses. So I am going to just focus it on pre-calculus. But the good thing about the pre-calculus course is even if you're not sure you really need it for the semester exam, it is also the same thing for the final exam. So what I do in there is I have my reviews that I gave to my students when I was teaching pre-calculus for the semester review as well as the final review. And then also I have a mock exam review. So therefore you can practice some questions for so actually practice, like actually do an exam. So I have that for, again, the semester exam and the final exam. All the solutions and recordings of me going through them are all going to be provided within the course as well as a live teaching component. So it is a lot of information. If you are taking pre-calculus and you're like, one of the things I always stress to students is if you need help, one of the things you got to do is you got to practice problems. And a lot of times students are like, what do you recommend as far as a website or a textbook or whatever else? Like, for all the other courses, like there's so much that's out there. Obviously the only thing I can recommend for students and that I can stand behind is obviously what I used to give my students inside the classroom. And that obviously would be the pre-calc exam. So I do have that. Inside of the description as well as inside the chat. So if you're interested in that, you can go and check it out. And also if you, I just actually uploaded my pre-calculus like first semester, just like exam review. If you just want to kind of see how that is, like, it's just maybe a cheap inside that you can just kind of go and see what that review looks like before, like if the full course is not something that you would, or getting the review, the answers, all that is kind of like not something you're interested in, or maybe like too much money for you, then maybe check out that exam review and see if that could help you out. But otherwise, Stephen, I am doing excellent. Well, Joss, I'm happy to be able to help any way I can. And thank you, CYCY Legit. Happy to be able to help you guys out. And I'm going to go ahead and get into these questions. If you guys, again, if you do have questions, I might be able to get to some extra questions that go in the chat. But the best thing that you can do is submit your questions via that link. All right. I can say, though, I am working from how questions were submitted to me. So therefore, if you submit it on the link, though, I'm probably not going to be able to get to, thing. But you can see how this problem is up. Like it's already posted on there. So that's why that's why I like to have them submitted so I can post them in there. But if we'll see how much time we have at the end, and I can maybe answer some questions for you guys that are live in the chat, because I do appreciate you guys showing up at this odd time and not even expecting me to go live. All right, so let's get into some of the questions. So this question came in for the graph fx is shown. Sketch the graph of each function state the domain and the range. Okay, so the main important thing here is I don't really care what transformations are going to be happening, right? All we're going to be doing is stretching, compressing, shifting left or right. So no matter what, the domain is always going to be the same, right? It's going to be from negative infinity to infinity. That's never going to change. You can see though, the range is going to change. So if I shift this graph up or down, right? Or if I'm going to be stretching this graph horizontally or vertically, or actually vertically, then that could affect the range because the range is basically going to be how low to how high is this graph going. And so right now you can see that this graph has a range of 1, 2, 3. Okay, so this is for the parent function f of x. Now what we're going to do is we're going to apply the transformations. Now, what's kind of tricky about this one is there's really kind of like 2 points that we really want to consider here. Like here's what actually, this point is 3 and this point is 1. Okay. So really like these are kind of like, I would say like these critical points here where the function is changing, right? From going down, decreasing down and going back to the slope here. So when I'm trying to like create a table of values, because that's basically what I want to do is I want to create a table of values. I want to say, all right, what happens to these points? Because I know anything to the left of that point is going to have the same y value. Anything to the right of this point is going to have the same y value, right? And there's basically like a direct line between them. But to find the range, like I need to know how high and how low those are going. So what I'm going to do is I need to try to pick an x value here that is going to give me a 1. So if you think about this, when you plug in a number, you're going to multiply by 1/3, right? So, well, think about this. If I plug in a 3, right, multiply by 1/3, that's going to give me a 1. So y is equal to a, well, let me do it this way. Let me show you what I'm doing. So basically I'm taking a y sub 3, right? That's going to be a 3 times f of 1/3 times 3, right? So I'm plugging in 3 times 1/3 is going to be a 1. So therefore this is a 3 times f of 1. Now let's go back to my original function, right? This is my original function fx. What is f of 1? Well, f of 1, right? If you go to 1, f of 1 is equal to 3. So it's equal to a 3 times a 3, right? Because f of 1, right? F of 1 is equal to a 3. You can see it right there. Okay, right there, 3 comma 1, or 1 comma 3, sorry. So therefore 3 times 3 is going to be a 9. Okay, now the other point is I want to get a 3. So basically, again, I'm going to be multiplying, what number should I multiply by 1/3 to get to a 3? That number is going to be a 9. So when I do a y sub 9, let's see what happens. So therefore that's going to be 3 times an f of, oops, not that way. So it's going to be a f of 1/3 times 9. 9 times 1/3 is going to be 3. So what is f of 3? Well, f of 3 here, so I go to 3 is 1, right? So therefore that's going to be a 3 times 1, and 3 times 1 is going to be a 3. So basically what happened here is this graph, you can see like we got to understand these transformations, right? So if you remember, this is going to be a horizontal stretch, all right? So this is actually going to be a horizontal stretch of 3. So the graph is being stretched horizontally. And then here, this is going to be a vertical stretch of 3. So if you remember your transformations, you can actually kind of understand what's going on. This graph is being stretched this way and being stretched that way. Now, if I was to go ahead and graph this, look what happens here if I graph a new one here. So now let's go and graph this. So this is going to be 9 comma 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. And then this point is going to be a 3 comma 9. Also 9, 9 comma 3. And this point is a 3 comma 9. So 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There. Okay. And it's kind of like the same pacing here. Now you can see here the domain is going to be the same. However, my range, so the domain is still going to be from negative infinity to infinity. However, my range here is going to be what? That's the lowest point now is going to be a 3. And the highest point is going to be a 9. All right, let's go ahead and do the B portion because the B portion is kind of like the exact same thing. But unfortunately, you should try to kind of see like what's happening here. This is going to be a horizontal compression, and this is going to be a vertical compression. All right, so this is a horizontal compression of 2 and a vertical compression of actually 2 as well, 1/2. 0.5 is the same thing as 1/2. So again, what I'm trying to get to is I'm trying to get to these two values. So what I need to multiply by, let's do 1 here. What do I need to multiply a 1 by? What do I need to multiply a 1 by 2? Or what do I need to multiply 2 by to get to 1? Well, hopefully you recognize I need to multiply a 1/2, right? So my points here, so my xy is going to be a 1/2. So let's go and figure out what y sub 1/2 is. All right, so I have a 0.5 times a f of, oh, sorry, don't probably need that. Thank you so much. 0.5 times y of 2 times a 1/2. All right, so 2 times 1/2 is going to be a 1. So what is f of 1? F of 1, right, we know is 3. What's 3 times 0.5? 3/2. So that's equal to a 3/2. All right, and then let's go ahead and try to get 3. So what do I need to multiply a 2 by to get to 3? That's kind of tricky, but that answer is going to be a 3/2. Okay, so if I did a y times a 3/2, and the reason why is because 3/2 times 2, the 2's are going to divide out. That's just going to leave me with a 3. So therefore, this is a 0.5 times an f of 2 times 3/2. Okay, and you can see what that gives me. That gives me a 0.5 times an f of 3. Okay, so f of 3, what does that equal to? A 1. What's 1 times 0.5? That is going to be a 1/2. So a 3/2 is going to give me a 1/2. Same kind of actually relationship that we had before, right? As you can see, like that's the exact same kind of relationship. And actually, let me just make sure I can add this down. Let me just give one more. So this is a 0.5 times an f of 1. Okay, so let's go ahead and graph that real quick. That kind of looks tricky. All right, so we have, let's do, here's 1. Let's do, here's 2. So the first one is at 1/2 and then 3/2. So 1, 2. So I went to 1/2 and then I went to 3/2, which is like 1.5. And then here I went to 3/2 and then I went only up to 1/2. So again, following the same pattern on my function, there's no reflection or shifting. The domain is still the same. However, what is now my range? So kind of running out of room, sorry. So my domain is all real numbers. But my range is, how low did this graph go? To 1/2. How high did it go? To 3/2. So the main thing I try to do is, kind of re-sketch the graph using a table, and understanding your transformation is very helpful. A lot of students, I'd probably say, would not remember the transformations or how that's going to impact the graph. Just recognize the domain is not going to be impacted. The only thing that'd be impacted would be the range. So you want to use your table of values. And I really just wanted to focus on these 2 points, right? Because those are the only 2 points that are really going to impact the change in the graph. So I only need to do this for 2 points, and I could understand the domain range from the graph from there. All right, so let's go move on to the next question. The next question says, to describe the transformations that occur to the function y equals 4x to produce the graph negative 4x plus 1 minus 5. Okay. So what I want you to understand is it doesn't matter if, like, a lot of students, I think, will sometimes get confused based on what the function is. Okay, so I want to show you something real quick. So this is going to be an x plus 1 quantity squared minus 5. And let's do a square root 1. So negative square root of x plus 1. Actually, let's do a cube root. Doesn't matter. Okay, the point that I'm trying to make for you is it doesn't matter what the function is. There's a couple things that I want you to really understand here. And actually, even for this one, let's actually go ahead and rewrite this. Y is equal to a negative 4 x plus 1 minus 5. Okay, so what are some things that we recognize here? In all 3 of these functions, this negative is being multiplied on the outside of the function, right? It's being multiplied either against like your number here, or against these parentheses, or against this radicand, right? It's outside of the function, right? And if you were to think about like, what do you mean? What are the functions? Well, we have one function, which is 4 to the x, another function, which is x squared, and another function, which is cube root of x, right? So if I was going to say it's inside of the function, it'd be the exponent. If it was inside this function, it'd be being squared. If it was inside of this function, it'd be taking the cube root. Okay, so these are all outside. So if it's outside, if you're multiplying by a negative outside, that is going to be a reflection of the x-axis, right? Yes. All right, now let's go and take a look at the next operation. X plus 1, x plus 1, x plus 1. What do we all recognize about these? These are all inside of the function, right? When you're adding a 1 inside the function, that's going to be a horizontal shift. Okay, and again, it's inside the function because it's an exponent for here. It's inside because it's being squared for the x squared, and it's under the radicand, right? So therefore, in this case, now we can say this is going to be a shift. Now this one is, you got to remember, when it's a horizontal transformation, it's actually going to be in the opposite direction. So this is going to be shift 1 unit left. Okay. Shift 1 unit left. And then the last thing we have here is my negative 5. And again, now we're not subtracting 5 inside the function. Inside the function was the exponent. This is subtracting 5 outside. So this is subtracting 5 outside. Inside the function is inside the parentheses. Outside is right here. Here's outside, there's inside. So since it's outside, this is going to be a vertical shift outside the graph, right? So therefore, this is going to be a shift 5 units down. Okay, so just remember horizontal shift is actually going to be like kind of in the opposite direction that you see that sign, whereas the vertical shifts will be in that same direction. So just kind of remember that. This one says use vertices and asymptotes to graph each hyperbola, locate the foci, and find the equations of the asymptotes. All right, hopefully I can remember these. So the main thing we want to do here is get this equation equal to 1. So what we're going to do is we're going to divide both sides by a 36. Okay, by dividing both sides by 36, I can reduce this. So 9 over 36 can be reduced to a 1/4. So this is a x squared over 4. And a 4 over 36 can be reduced to a 1/9. So 1/9 times y squared can be written as a y squared over 9. And that's equal to 1. All right. So now we have this form. Let's kind of go back and write the form of a hyperbola for this. So we have a x minus h quantity squared all over a squared minus a y minus k quantity squared all over b squared is equal to 1. Okay? Okay. So we need to use the vertices and asymptotes to graph each hyperbola. Okay. Well, we're not using they actually want us to graph this. Okay. And then locate the foci and find the equations of the asymptotes. Okay. So to find the foci, we need to find C. Okay. So, first thing we need to know is kind of like the vertex. Vertex is going to be your HK. Notice how we're not adding or subtracting anything to my X and my Y. So therefore, let's say 0, 0. All right. To find C, the cool thing about C is a squared plus b squared is equal to c squared. It's not it is the Pythagorean theorem, but that's just an easy way to remember it for the hyperbola. At least that's the way I always like to remember it there. So, and therefore, in this case, we have a 4 plus a 9 squared equals a c squared. Okay, so 4 squared is going to be 16, plus 9 squared is going to be an 81 equals a c squared. I'm not sure. It's going to be a 97. No. 97. I don't think that's going to be... Oh, what am I doing? It doesn't really matter. So therefore, that's going to be 97 equals c squared. And if you take the square root of both sides, you can say c is equal to a square root of 97. Okay? All right, so that's going to be my distance away from my hyperbola. Now, the next thing I need to identify, though, is my foci going to be up or down or left or right? And the way that we can determine this is our a squared. Our a squared, for a squared is under an x, then it's going to be horizontal. Our transverse axis is going to be horizontal. If our a squared is under our y, then like if these two were flipped, right? If this was actually a y squared minus x squared, then my transverse axis, which my foci and vertices lie on, would be vertical. So that is not the case here. So therefore, we have a horizontal transverse axis. So I'm actually going to sketch this. Okay, so we have it 0, 0. All right. So we're going to go C distance. Oh, we do need to find our A, right? So what is actually the square root of 97? Just so I have a decimal approximation, 9.8. Okay. Okay, so that's approximately 9.84. Oh, yeah, it's not always a bigger. Yeah. All right. So anyways, so we have X. Here's our origin. So our vertices here are going to be at a distance of 2, right? So that's A. So that's going to be a 1, 2. There's a vertice, 1, 2. Now to find the asymptotes, that's going to be our, what is it? I got to remember this. I think it's A over B, if I remember correctly. Let's just go and let's grab this. It'll be 1, 2, 3. Yep. Okay. So that'd be 1, 2, 3, and then 1, 2, 3. Okay. So what you can do, what I like to sometimes do is create like a nice little box. Okay. So my asymptotes here are going to follow this form. Okay. So where these intersect for my vertices and my minor vertices. Again, you can identify this. A is equal to the square root of 4, which is 2. and b is equal to the square root of 9, which is going to be 3. So that's how I went 3 up, 3 down, 2 left, 2 right. So anyways, that's going to be 3 over 2. So yeah, the equation of an asymptote is y equals plus or minus. That's going to be an a over b times x minus h plus k. Okay, so that is going to be the equation of my asymptote. So y is equal to plus or minus. That is just going to be a 3/2 x, right? And you can see that's exactly how we had that as graphed. And then this is like 9.7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my foci is like right there. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, somewhere right there. And then again, just remember, this is going to get kind of hard, but when you are graphing this, let me just do a different color. Then you are approaching. So here is my vertex, right? Vertex. So just remember you're approaching these asymptotes. That's my foci. That is my other foci. Whew, okay, there you go. Let's move on to the next one. So this one says, rewrite the equation by completing the square. Your equation should look like this. Okay, so when we're completing the square, first thing you want to do, or in this case, actually, yeah, we got to get all the x's. Let's just set it equal to 0. Let's just keep this on a, let's just try to keep this consistent. Let's get everything over to the right-hand side. So if I get everything over to the right-hand side, subtract my 3. I got some answer choices down here below, so that's good. So 0 is equal to a x squared plus 3x minus x is going to be a 2x and then minus 3. All right. Now, this is actually 3 times 2. Actually, looks like it is factorable, so you could probably actually go ahead and guess and check, like find the answer by factoring and then find your answer there. Or you could also go ahead and use the quadratic formula, right? So if you're taking a test, utilize those. But I will show you what it's going to look like for completing the square, because it does say you need to rewrite it that way. But you could always work backwards and then work up if you kind of like have a general idea what's going on. So to complete the square here, we're just going to take our middle term divided by 2 and square it. So 2 divided by 2 is 1. 1 squared is going to equal 1. So what we're going to do is we're going to add that number. So x squared plus 2x plus 1. We're going to subtract that number and then minus the 3. Okay, so -1 minus 3 is a -4. This can be factored down into a quadratic squared, so therefore that's going to be an x plus 1 quantity squared minus 4, and then they wanted to write it in this format, so therefore I'd add a 4 to the other side. Oh, because yeah, technically, I'm sorry, that's equal to a 0, right? I forgot to keep on writing that. So now we have a 4 is equal to a x plus 1 quantity squared, or as they wrote it, x squared plus quantity 1. And then your answer, though, if you were to solve this, is 4 equal to an x plus 1 quantity squared. So you take the square root of both sides. That's going to be plus or minus 2 is equal to a x plus 1. Subtract a 1, subtract a 1, so that's a -1 plus or minus a 2 equals x. And you can see that answer is going to be D. All right, 2 more questions. So is y3 to x a shift 5 units to the right? No. Just remember, when it's a horizontal transformation, that's actually going to be shifting it to the right. But that's a great question, because students get confused all the time. So what I want to do is let me just give you a quick little tip that you can use. Let me give you a quick little tip that you can use to go ahead and solve this, okay? So what if I had y equals a 3 to the x minus 5? You're like, crap, is that shifting to the right or shifting to the left? Well, let me show you something. What am I doing? Why don't you go ahead and do this? If I had x and y, right? Okay. If I had x and y, table functions. All right, let's do y equals a 3 to the x. 3 to the x, what am I trying to do? Minus 5. Okay, what you want to do is think of a table of values that's going to make this 0 and make this 1. So the first number that's going to make that 0, it'd be a 5, right? That's what I want to do, right? Is that what I'm doing? I can't remember what I'm doing. I can't remember what I was going to do. I am going to make this 5. So let's go and figure it out. So if I plug in a 5, 5 minus 5 is 0. 3 to the 0 is going to equal a 5 to the 0 is going to equal excuse me, 5 to 0 is going to be 0, 3 to 0 is 1. Okay, so minus a 5. And then let's do another one would be, what if I did 6, right? If I did 6 here, 6 minus 5 is going to be 6 minus 5. 6 minus 5 is 1. 3 to 1 is equal to 3. Okay. So hopefully you'll recognize like the generic form here of this graph. So y is equal to a 3 to the x with no transformations. Should look something like this, right? Okay. I'm trying to think of, is this the best way I wanted to have put it in? So right now we have 2 points. We have 5, 1 and 6, 3. So 1, 2, 3, 4, 5, 6, 1, 2, 3. And we have 5, 1. So 5 to 1. Okay. So this graph looks something like that. So, oh yeah, well, yeah, there we go. Never mind. Fine. So we graphed these 2 points, right? We found 2 points here. And to go from here to here, what happened? When I did x minus 5, what did that do? Did that shift the graph to the left or did that shift the graph to the right? It went to the right. So I'm assuming, again, how the student wrote that, I should probably clarify. Sorry about this. I should clarify. I was assuming this was 3 to the x minus 5. Okay. So that would be 3 to the right. And you can see how that worked. Now, if it was y is equal to 3 to the x minus 5 like this, well, again, now we can do now we can do it again, but I'm going to pick different numbers here. Okay. So if I wanted 2 different numbers, let's go and do it this way. If I said y is equal to 3 to the x minus 5, how would it work? How would this work? Or how would this look? Well, the way that I'd make this one look is I would say, well, I'm not going to choose, 5 and 6. I'm going to choose like 0 and 1. So what if I plugged in 0? So if I plugged in 0, right, I would have 3 to the 0, which is 1. 1 minus 5 is negative 4. And let's just plug in 1. 3 to the 1 is 3. 3 minus 5 is a negative 2. Let's plot those 2 points. 0, negative 4. 1, 2, 3, 4. And 1, negative 2. 1, 2. See what that graph is? What happened? That took that graph down, right? That took it down 5 units. So hopefully you can kind of see, like, you got to know the parent graph. And then, yeah, if you get stuck, that's fine. Just create a table of values and you can kind of see how that works. All right. And then this one says, choose by clicking the graph. I can't click the graph. So find the angle theta if secant of theta is equal to a negative 13/5 and tangent of theta is negative. Okay. So we need to know when tangent is negative. Now, again, remember, like, here's a coordinate point. Here's x, y. Well, remember, tangent of theta is y over x. So if I have y over x in the first quadrant, that's going to be positive, right? So tangent is positive. If I do it over here, that's a negative x, negative y. Negative y over negative x is going to be a negative, right? So that's also a positive. So the only 2 quadrants that tangent can be, tangent is going to be negative is in the second quadrant as well as in the fourth quadrant. However, secant of theta has to equal a negative 13/5. Now 13 is the hypotenuse, right? Hypotenuse. Secant of theta is going to equal like r, hypotenuse, over x. So in this case, my hypotenuse is never negative, but my x has to be negative. So it can't be in the fourth quadrant because over here in the fourth quadrant, my x is positive, right? I'm going to the right. So that's not going to work. So therefore my equation has to be over here. All right. And so therefore this is going to be 13. This is going to be a negative 5. Using my Pythagorean triples, I recognize this to be a 12, and it's going to be positive because we're going up. And then in this case, I can now go ahead and evaluate, right? So, I mean, I could do anything I want. I could do, tan inverse here of a 12 over a negative 5. Now, there are some interesting things, though, that's coming into when you do a tan inverse of a negative, because the answer you're going to get is only, if you remember, when you do like tangent inverse of an angle, that's going to be restricted here between the first and the fourth quadrant. So I want to actually, I'm trying to think here. What do they do? Tangent inverse. Okay. Yeah, they're being negative. Okay. Tangent inverse. Okay, so when I do this, tangent of this, I get a negative 67.38 degrees. All right, and I'm just rounding to the nearest tenth. Now that's interesting because that's not negative degrees. If I was going to go from here to here, that is not negative 67 degrees. But again, you got to remember, tangent's not going to give you this angle. Our tangent inverse is not going to give you this angle. It's given us negative 67.38 degrees, which is this angle, right? So what it's doing is it's giving us this reference angle technically here. So therefore, what that means is like, if this is 67.385, that means this is also going to be a 67.38. All right. So then what I need to do is to go ahead and find this angle, which is going to be my theta. I just need to take 180 degrees minus 67.38, or exactly my last contract. So I'll do 67.38 minus that last answer, but I'm using the positive version, and that is not correct. What am I doing? Oh, 180 minus 67.38, 013505. Gotcha. And that is going to give me a theta is equal to 112.619 degrees. So there you go, ladies and gentlemen. Hopefully this was a helpful little sim. I will be planning on going live tomorrow. I am going to plan at the same time, but don't hold it to me if I'm not able to make it. So again, if you do have questions, guys, go to brianmclogan.com/Q&A. If you are taking pre-calculus and you want something like this for you to get ready for your exam, then you can go ahead and sign up for the course at brianmclogan.com/PC exam. If you have any questions, feel free to reach out to me on Instagram, or you can also go ahead and check out the Discord server and reach out to me there. So otherwise, guys, hope you guys have a great rest of your evening. Hope you work on studying and have a great rest of your week. All right, guys, talk to you later. Cheers.